Today, I will start with a new topic, which is deflection. In this course, I will cover many topics related to deflection. What you mean by deflection? Let's start with the first expression, displacement. Displacement is the degree to which a structure element is displaced under a load. It may refer to angle or distance. I'm sorry, what you mean by angle or distance, what you mean by displacement. Let me explain it first in a very simple way. If you have piece of wood, piece of wood, and this piece of wood is rested on two chairs, and you are walking on this piece of wood. You are standing here. Before standing, before anybody on this piece of wood, do you have any concern about this piece of wood? No, I don't have. This piece of wood looks like a beam supported here by support and supported there by support. Nothing will happen. What will happen if this piece of wood, guys, nothing. This line is a straight line. This line is a straight line. Straight line because we don't have anything. But if you are walking on this piece of wood, so I believe this piece of wood will bend like this. Do you agree? Do you agree? I think you are agreeing with me. So the new shape, after you apply a force on this piece of wood, the new shape or the new position or the new deformed shape for this piece of wood looks like this. Curve. So the original position of this point moved down to a new position here. So we have distance. We have distance. This point moved a distance. The original position for this point, for example, was on a straight line. So the tangent for a straight line is a horizontal line. But the new position for this point is moved here. So we have a curve. If you would like to draw a tangent, we will have a tangent with angle theta with the horizontal. So we have angle. So any point here will have distance. It moved distance and rotate angle theta. So we have displacement. That makes sense? Believe me, if your piece of wood is converted to a beam, concrete beam or steel beam in a real building, and you have load coming from any reason, this load or this force will cause deformation of the structure. This deformation can be divided to distance or deflection. The point moved down by distance. This distance called deflection. The original position of the node on a horizontal line, so the tangent is horizontal. We don't have theta. Theta equals 0. But later, after deformation, the same point on a curve. Any curve has tangent with angle theta with the horizontal. So we have a slope or angle theta. So displacement can be divided to movement, which is called the deflection, and the slope, which is called rotation, theta. So guys, displacement can be divided to slope. It is angular shift at any point of the beam between no load condition. No load condition, yes. Before deformation, the beam is a straight line. No load condition. And the loaded beam, after you apply a load, we have a new position. Its value is different at different point on the length of the beam. Deflection. So this one is angular shift. Angular means rotation. Theta, slope. Deflection means it is the vertical shift, displacement of any point on the beam between the no load condition and the loaded beam. One more time. One more time. It's very important to understand these concepts. We have a beam. Before applying this load, which is called no load condition, the beam is straight line. Can you see? It's a straight line. Once you apply this force, the new position of the beam looks like a curve. This curve. For example, can you watch this point? This point in the new shape moved down to this position. And we have tangent, and this tangent has angle theta with the horizontal. So we have deflection, which is the vertical movement. We can call it y. And we have a slope or rotation, and we can call it theta. I understand you cannot watch this deflection and the slope in the real life structure, but believe me, in your building right now, in your apartment where you are sitting, believe me, there is a deflection, but it's very, very, very small. But we have deflection. We have deflection. Any questions so far? Do you have any questions so far? So we are talking about a new topic called deflection and slope. To be more clear, let's watch this video.
So again, a simply supported beam with overhang. A is a hinge support.
We have a beam here. This beam is supported at A with a column, at B with a column, and we have cantilever. Without any load, without any external load, the beam is a straight line. The beam is a straight line, no deformation. So see what will happen if we apply load.
And B is a roller support. Now, if we apply two concentrated loads to this beam, we would like to see how would it deform. So one concentrated load is applied at the tip, and the other one is somewhere in between A and B. So now let's watch the deflected shape.
Can you see the new position or the new shape of the beam after you apply two concentrated load? The first one at the tip of the cantilever, the second one at between A and B. Any beam in the real life must be deformed like this. I know we cannot watch this deformation because it's very, very, very small. But there is deformation for any structure under load.
So what we can see here is at point A, again, there's a rotation. At point B, a different rotation. And between point A and the first concentrated load, the beam deforms into a concave shape. But after that concentrated load, all the way to the tip, we can see that it is a convex curve. So now, obviously, there is a controflexural point along the deflected shape of this beam. And the controflexural point is somewhere here.
So I can tell you this new shape, this new curve of the new shape of the beam after you apply a load can be called elastic curve or deformed shape. For example, if you are in a job interview as engineer and the interviewer asked you, hey, if you have a beam and you have concentrated load here, can you draw elastic curve? Sometimes this is a question in the FE exam or professional engineer exam. Or can you draw the deformed shape? So you have to remember that elastic curve and the deformed shape, both of them are the same meaning. Elastic curve or deformed shape means this beam under without any load looks like a straight line. After you apply a concentrated load F, I believe this beam will be like this, as a deformed shape, or the deformation of this beam will be looks like a curve, like this. This curve is called elastic curve or deformed shape. So until this moment, we learned what is the meaning of displacement. Displacement means deflection and slop. Slop means rotation. Deflection means vertical movement. The new shape of the beam or the structure or the frame or the truss or any structure, the new shape after you apply loads is called elastic curve or deformed shape. We have many methods that can be used to figure out what is the value of this deflection, what is the value of this slope. We have first method, double integration method. I will start with this method today. We have another method, conjugate beam method. Both of them can be used for beams only. We have another very powerful method which called energy method. We will cover virtual work for beams and virtual work for trusses. This energy method called virtual work I will cover for beams and trusses. So let's start with our new topic or our method, double integration method to calculate slope and elastic curve for a very simple beam. But before doing this, I would like to show you something on RISA. I will show you something on RISA. I have a beam. This beam made from concrete with cross section looks like rectangle. The width is 0.12 meter and the depth is 0.24 meter. This beam has hinge at A, roller at B, 2 concentrated load 8 kilonewton and 4 kilonewton. And I would like to model this beam on RISA. Just a reminder, I will assume my origin is here. Here is the x-axis. Here is the y-axis. I believe I will put coordinate at 0, 0, at 3, 0, at 6, 0, at 9, 0. Do you agree? Let's see. Here is the RISA 2D. Insert, joint, I said 0, 0, 3, 0, 6, 0, 9, 0. That's right. If you would like to hide this grid, view, drawing a grid, here you go. We have 3 nodes. Node number 1, node number 2, node number 3, node number 4. Remember, this is node number 1, node number 2, node number 3, node number 4. That makes sense. The next step, insert members, concrete. I will define the shape. I have a mistake here. I did a fatal mistake. One should remind me before starting. Anybody can tell me what was the mistake? Guys, do you know what is the mistake? Thank you. Thank you, Marcus. Yes. Yes. This problem, everything in meter and kilonewton. The default unit in RISA before starting is US unit, pound, feet, inch. So you must, before starting at the beginning, before doing anything, you must go to a unit and you can use standard metric. Standard metric to make sure your length will be in meter, your force will be in kilonewton. You have to do this before doing any single action. Okay, go ahead and start. View, drawing a grid, insert, joint, 0, 0, meter and meter. Then 3 meter, 0, 6 meter, 0, 9 meter, 0. If you did this mistake again, you have to start from scratch, like I did. Here you go. Insert members, concrete. The material is concrete. Dimension here in millimeter, that's fine. So the depth will be 240 millimeter. And the width is 120 millimeter. So this width is 120 millimeter. The depth is 240 millimeter. Okay. Apply. I will draw members between these nodes. At this node, we have hinge. So insert boundaries. We have bend. Apply. Here you go. One more time, insert boundaries. We have roller. apply. Here you go. What else? We have concentrated load here, 8 kilonewton, and I have node. So insert joint load in y direction, -8 kilonewton. Apply. Here you go. One more time. Insert joint load -4. Apply. Here you go. We are good. 8, 4, the beam, hinge, roller, everything is good. So before solving spreadsheet, load combination, be careful about this step. For the first one, basic load case, I will use basic load case 1. Okay. The scale factor must be 1. Then I will close this window and I will start to solve. Let's see. We learned before the first exam that we have axial force, which is 0. We have shear force. We have bending moment. All of this stuff we learned before the first exam. We learned also how to get the horizontal reaction, how to get the vertical reaction, how to get the moment if you have. We learned all of this stuff. Do you remember that? Okay. What we need to learn, we have something here called deformed shape or deflected diagram. If you open it, I can show the deformed shape with the undeformed shape. Can you see? What is this? This is the deformation. This is the deformation that we need to learn in the new topic, starting from today. Deformation. Deformation. One more thing. If you go to results, joint deflection, here you go. Do you remember we have node number 1, node number 2, node number 3, and node number 4. Here you go. We have 4 nodes. The first node does not move in X direction, does not move in Y direction. That makes sense because node number 1 is hinge and the support hinge does not move. Node number 2 moved down. That's right. Do you agree? Guys, do you agree? Node number 2 moved down. Here you go. In X direction does not move. That makes sense. In Y direction, which is vertical, moved down. How much? Negative means down. 8.6 millimeter. So point node number 2 moved down. That makes sense because we have concentrated load, would like to try to push this beam down. So node number 2 moved down. How much? Negative means down. How much? 8.6 millimeter. For example, node number 4 moved down. How much? Why down? Because it's negative. How much? 51.3 millimeter. So Risa can draw deformed shape, and also from results, joint deflection, this window can show you what is the deflection and also what is the rotation, theta. What is the rotation, theta, for every node in the beam. We can calculate these values, which is vertical deflection y or rotation theta, by using this method. So did you understand what is going on? Guys, did you understand what we need to do starting from today until probably the end of the semester? We have a beam and we have applied load. The applied load will make deformation. So we need to calculate how much this point will move down, how much this point will rotate, because the new shape is a curve, and this curve has tangent at each point, and this tangent has rotation, slope, angle. How much all of these values? We will learn how to calculate these values by using double integration method, by using conjugate beam method, by using energy method. Anybody has any question? Anybody has any question so far? Guys, do you have any question? Do you have any question? If you have any question, let me know, please. Okay, let's start with the first method, double integration method. Double integration method is a powerful tool in solving deflection. Why? Slope theta y and theta at any point, y and theta at any point of a beam at any point, because we will be able to get the equation of the elastic curve. We have 7 steps. Unfortunately, I have, sometimes it's a good news, sometimes it's a bad news. These 7 steps, the first step of them is you have to calculate reaction of the beam. If you have a beam, you have to calculate first what is the reaction, or what are the reactions of this beam. Then we need to establish a distance x. At this x, we will do cut and put the moment in the positive direction. Then I will express what is the value of moment as a function of x. Then I will apply the equation, which requires 2 integration. For each integration, it is important to include a constant of integration. This constant will be determined according to something called boundary condition. Once you set up your equation, I can determine what is the slope, what is the deflection at any point. Keep in your mind the positive value for slope means counterclockwise, the positive displacement means upward. Looks like we didn't understand anything. We will do example and see how we can set up these 7 steps. And remember, the most easy method in this topic is this one. It's very easy. Don't worry about these 7 steps. They are nothing. They are nothing. But before starting, I would like to show you something. This mathematical expression called Bernoulli-Euler beam expression. How can I read this expression? Anybody has good experience with mathematics to read this expression? I need to listen to you. Anybody can write what is the expression? How can I read this expression? Anybody can tell me what is the meaning of d2y by dx squared? Anybody can know what is the meaning of this expression? Any response? You should learn it. You should learn mathematics before, I believe. So do you know what is the, how can I read this expression in math? Looks like a derivative. Okay, good. But how can I read it? By the way, y is the deflection. Y is the deflection. Y, deflection. X is distance. So how can I read this expression? You should know. You should know. Guys, in math, I can read this expression like this. Second derivative of y related to x. Second derivative of y related to x. d2y by dx squared. d2 means we have two derivatives. Second derivative of y related to x equal moment. M means moment, divide e I. Divide e I. Any question? Second derivative of y related to x. Any question? Second, thank you, Ben. Second derivative of y related to x. I will talk about math. So, second derivative of y related to x means if you do one integration, what you will get. If you do one integration, I believe I will get first derivative of y related to x. If you do one integration. If you do another integration, one more integration, I will get what? And y is the deflection. By the way, the first derivative of y related to x is slop, theta. Just to remind you, our target to calculate what is the slope theta, what is the deflection y. This mathematic expression is second derivative of y related to x. I will do one integration. This first integration will give you dy by dx, which is the first derivative, can be called the slope theta. If you do another integration, I can get the value of y, which is deflection. That makes sense? That makes sense. One more thing. The second derivative of y related to x, Bernoulli expression said equal m divide ei. I understand what is the meaning of moment. We learned it before. Moment means force time distance. Yeah, I understand this. But anybody can tell me what is the meaning of E? What is the meaning of I? You guys are junior student right now in spring semester. That means you passed the mechanics of material course with Dr. O. So anybody can tell me what is the meaning of E? Any answer? I will tell you, Young's models. Or sometimes modulus of elasticity. Okay, yeah, probably we learned something about this expression. So anybody can tell me what is the meaning of Young's modulus or modulus of elasticity? Do you know? Thank you, Marcus. Yes, thank you. Elasticity and the moment of inertia. Perfect. 100% perfect. So what is the meaning of modulus of elasticity or Young's modulus? Anybody know or remember? How can I get this value, or what is the meaning of this value, or something like this? Do you remember? Okay. We have something called stress, strain, diagram for steel. For example, if you have piece of steel or rod of steel and you apply tension test, this tension test will, if you apply a force, we can expect elongation. This elongation and this force can be converted to stress strain curve, and your curve looks like this. We learned in mechanics of material that the relationship between strain and stress for steel, for example, looks like this. We have initially a linear relationship. This linear relationship in the elastic region. This line has slope. This slope can be called modulus of elasticity or Young's modulus, E. Anyway, I called moment of inertia. During the engineering mechanics, we learned that if you have rectangle, cross section looks like this rectangle for the beam that we defined in RISA. The moment of inertia I called parallel time h cube divide 12. So E depend on the material, I depend on the cross section. Anyway, and M is the bending moment. This expression equals second derivative of y related to x. I'm trying to explain what is the meaning of this expression. The moment convention, any moment would like to make your member to smile. Smile. All the time, smile. So your moment would like to make this member to smile. For deflection, if this deflection moved up, the deflection will be positive. Do you remember? For this deflection, what is the value of y here? For node number 2, what is the value here? Negative. Means the point moved down. The point moved down. What will happen if y is positive? The point will move up. So the direction or the positive or the sign convention, y is positive, that means the point moved up. Y is negative, that means the point moved down. That makes sense? Theta is positive if the rotation is counterclockwise. 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 Negative means if it's clockwise rotation. We have boundary condition. Why we need boundary condition? It's a mathematical problem. Can you see here? We will do one integration to get a slope. We will do another integration to get deflection. Each integration will create constant of integration. If you have constant of integration, that means we need to figure out what is the value of these constant. So we need something called boundary condition. Boundary condition means if you have support, roller, or hinge, y or deflection at this support will be 0. That makes sense? That makes sense. Do you know why? Do you remember the piece of wood? Do you remember the piece of wood which is supported on this chair and this chair? If you apply a load, the new deformation of the beam or the piece of wood looks like this. Every point on the beam moved down, moved down, moved down, moved down, moved down, except this point and this point does not move, does not move. This point doesn't move. This point doesn't move. Do you know why? because we have support. We have support. So if you have a support, the point will not move. That makes sense. If you go back here, node number 1, it's a support, y equals 0. Node number 3, it's a support, deflection, or y equals 0. No movement. That makes sense. If you have a support, hinge, or roller, we don't have deflection. But if you have fixed, no, fixed is special. We don't have deflection or slope. So deflection will be 0, and the slope also, theta, will be 0. Because we don't have fixed here, so I cannot explain it. But keep in your mind, if you have fixed support, at this fixed, deflection equals 0, slope equals 0. If you have roller or hinge, deflection only equals 0. I don't know what is the value of slope for roller or hinge. But if you have fixed, both of them will equal 0. Let's start our first example. Example number 1. We need to determine the deflection y and the slope theta at the cantilever tip at this point. By the way, this beam has a fixed here. It's not clear. Okay. For the shown beam, if W, the applied load equal 5 kilonewton per meter, and the length equal 10 meter. EI is not given, but it's a constant. Anyway. So this topic in our course will ask you for a different story. We will not ask for reaction. We will not ask to draw bending moment or axial force or shear force. We will not ask for unbalanced line. No, we will ask a different story. I'm going to ask you about what is the deflection value, what is the slope value at a specific point. In this case, cantilever tip, which is the last point of the cantilever. How can I start? How can I solve? We have 7 steps. What is the first step? What is the first step? Reactions. For this fixed, we have 3 reactions. Go back to the chapter number 1 or 2. If you apply summation f of x equals 0, this reaction equals 0. This distributed load has equivalent equal 5 times 10 equal 50 kilonewton. If you apply summation f of y equals 0, I believe this reaction will be 50. If you apply summation moment at point A equals 0, assume, for example, this direction is positive, I believe this moment will be 250. So first step, we need to figure out what are the reaction values. So if you cannot figure out what are the reactions, unfortunately, you will not able to solve this problem. Any question so far? Guys, do you have any question? If you have any question, please let me know. Second step. I will do a cut. Where? anywhere, at any location as you like. This location will be at distance x. Next step, do cut at any distance x, at any location you would like, any position. Once you did your cut, you have to decide. We can use the right part or the left part. I would like to use the left part, will be the perfect choice. So what do you have on the left part? We have here the cut. This distance is x. We have vertical reaction here 50. We have horizontal reaction here 0. We have moment here 250. And we have part of the uniform distributed load, 5 kilonewton per meter. At your cut, we have moment. How can I assume this moment? This moment would like to make this part of the beam to smile. That makes sense? I don't care about any shear or axial force at this cut. My concern is moment only. So it's very easy. And these steps looks like they are not new for us. First step, reactions. Second step, do cut at any location at distance x. Oh, I forget something. Your distance x must be start from left. Don't start from right. We don't like this. So I will assume distance x from left. Then do your cut, use the left part, put your reaction, the part of the distributed load, this part, and at your cut, we have moment. By the way, this equivalent force will be 5 times x. So we have 5x. And this little distance will be x divided 2. That makes sense? Can you take moment at the cut? So summation moment at your cut will equal 0. Assume this direction is positive. So we have m, we have positive 5x, this equivalent force, time distance, x divided 2. We have positive 250, and we have negative 50 times x equals 0. Guys, to remind you, this moment does not need distance. So I use the m and the 250 without distance. This equivalent force, 5x, will need distance, x divided 2. This reaction will need distance, which is x. That makes sense? Can you make this moment in one side and everything on the other side? Can you? Yeah, the other side will be, probably we will start with negative 250, positive 50x, negative 5 divided 2 x squared. If you set up this equation correctly, you are done 90% of the problem. If you can set up this equation for m as a function of x correctly, you are done with 90% of the problem. For me, I will give you probably, if this problem is 20 points, I will give you probably 16 or 18 points. So guys, we are done with the most important steps. First step, you have to calculate your reactions. Second step, you need to do cut at distance x from left. Once you did your cut, I will use the left part. At your cut, we have a moment. Get the summation of moment at the cut. We have M, we have this force time distance, we have this moment, we have this reaction time distance. So I set up equation. I will put the value M in one side and everything in the equation on the other side. If you have any question, please let me know. If you have any question, please let me know. So right now, your moment M equal 250 minus 50x. That's right. No. Negative 250 plus 50x minus 5 divided 2 x squared. Here is the equation of moment. The following step is I will apply the expression of Bernoulli. Second derivative of y related to x equal m divide EI. 1 over EI outside. We still have m. Your m equal negative 250 plus 50x minus 5 divided 2 x squared. Second derivative of y related to x equal to this expression. Mathematically, go ahead and apply the first integration. If you apply first integration, I will get dy by dx, which is theta. 1 over EI is constant, keep it outside. Go ahead and apply integration for this term. It will be negative 250x. Do integration for this expression, 50 x squared divided 2. Go ahead and apply integration for this term will be 50 x cubed divided 6 plus constant C1. So hopefully you can do integration. If you have x, for example, and you would like to do integration, increase the power by 1. The power here is 1, so increase it by 1, it will be square, and divide with the new power. If you have x squared to do integration, it will be x cubed divided 3. If you have x to power 3, if you do integration, it will be x to power 4 divide the new power 4. That makes sense? That makes sense? And remember, if you have 5x squared, so 5x cubed divided 3. That makes sense? So it's mathematical problem right now. I have another question. What is the meaning of C? Yeah, because you did integration, which is unlimited. So this constant is called constant of integration. Can you do another integration? Yes, I can. So one more integration will give you y, because right now we have dy by dx. If you do a one more integration, you will get y equal 1 over EI. Do another integration for this expression will be negative 250 x squared divided 2. Another integration for this term, it will be 50 x cubed divided 6. Another integration for this one will be 5x to power 4 divided 24. Integration for C1 will be C1x. We have C2. I'm sorry, what you mean by C2? Guys, you did another integration, so we have another constant. So right now, we have two constant of integration, C1 and C2. we need to figure out what are the values of these constant. So we have something called boundary conditions. As I told you before, we have only these boundary conditions. If you have roller, deflection equals 0. If you have hinge, deflection equals 0. If you have fixed, both of them, deflection and the slope, both of them equal 0. So what do you have in this example? What do you think? Do you have a roller? No. Do you have hinge? No. Do you have fixed? Yes. So we have fixed support. Deflection equals 0. Slope equals 0. Add this support. Do you know what is the value of x for this fixed? Do you know how can I reach to this fixed? What is the distance x? Do you know? Yeah, I know. I can say at x equals 0. Remember, here is the beam, here is the fixed, and we are measuring distance x like this. So at this location, at this fixed, what is the value of x? 0. At x equals 0, theta equals 0. That makes sense? That makes sense. So what should I do? Here is the equation of theta. Theta equals 0, equal 1 over EI. And we have negative 250 times 0 plus 50, 0 square divide 2, negative 50 cube divide 6 plus C1. I believe this term will be 0, this term will be 0, this term will be 0. 1 over EI will cancel by 0, so C1 equals 0. You are lucky. Second boundary condition. This is the first one. Second one. At x equals 0, so you are at the fixed support, y equals 0. Deflection. Guys, remember, I told you, if you have fixed support, both of them will equal 0. Deflection and rotation. So we have another equation here for y. We have another equation here for y. So I can say 0, which is y, equal 1 over EI, negative 250, 0 square divide 2. 50, 0 cube divide 6. Negative 5, 0 to power 4 divide 24. C1, which is 0. C2. I believe this term will be 0, this one will be 0, this one will be 0. 1 over EI will be cancelled by 0. C2 equals 0. So based on the boundary condition for this problem that you have fixed, I found the constant of integration equals 0. So the final conclusion is your theta will be 1 over EI negative 250x positive 50x squared divide 2 negative 5x cubed divide 6. And the C1 equals 0. Y equal 1 over EI negative 250x squared divide 2, 50x to power 3 divide 6, x to power 4 divide 24. C1 and C2 equal 0. This is the final equation. What is the required in the problem? We are looking for deflection, y, theta, slope at cantilever tip. Anybody can tell me at this tip, what is the value of x? X is starting from left. What is the value of x? So I will say at x equal 10 meter, theta equal 1 over EI. Negative 250 times x 10, 50 times 10 squared divide 2, negative 5 times 10 to power 3 divide 6. What is the value? Negative 250 times 10 plus 50 times 10 squared divide 2 minus 5 times 10 to power 3 divide 6. This value will be negative 833.33 divide EI. Because this theta is negative, it's clockwise. Yeah, I told you here. If theta is negative, it's clockwise. Okay. What is the value of y? I will use the equation for y. 1 over EI, negative 250 times 10 squared divide 2 plus 50 times 10 to power 3 divide 6 negative 5 times 10 to power 4 divide 24. What is the value? Negative 6,250 over EI. The value of y equal negative, that means this point moved down. As I told you, if your deflection is negative, that means the point moved down. If the deflection is positive, that means the point moved up. So right now, I can tell you that the rotation or the slope at the tip point of the cantilever equal to this value. And the deflection at this point equal this value, 6,250 divide EI. So if I can give you the youngest modulus of the material, if I can give you the inertia, I can tell you the final deflection. You remember? If the material is concrete, E of concrete, I think equal 30,000 PSI. I think. The moment of inertia for this one equal parallel 0.12 times 0.24 to power cube divide 12. So if you can give me what is the cross section, I can calculate the moment of inertia. I can get the youngest modulus. Then I can go to these two values, both EI, to get the final value, to show you what is the deflection, what is the rotation. I will continue next meeting to do more example on double integration method.